Welcome everyone. Today I'm excited to talk to you about how you can manage your Kubernetes clusters with Azure Linux. My name is Sudhanva Huruli. I'm a principal PM on the Azure Linux team, working closely with the AKS team to offer Azure Linux as a node operating system for your AKS clusters. So the agenda for today's short talk is going to just be a brief overview of Azure Linux. So what is this Microsoft released Linux distribution and how does it work on AKS? What are some of the benefits I may see if I am interested in AKS or already using AKS if I switch to Azure Linux? I will show a brief demo on something called pod sandboxing. And please feel free to drop your comments, questions in the discussion below, and we'll be happy to respond on the channel. So what exactly is Azure Linux? So at its core, Azure Linux ships the upstream Linux kernel, but we optimize it for the Azure infrastructure by ensuring we have support for our Azure host, which is based on Hyper-V, across both cloud and edge. We tune this kernel for performance best for our infrastructure, harden it with secure defaults, and we ensure we are supporting all of the silicon architectures that are available in Azure. This includes x86 and ARM64. The distribution actually builds over 10,000 packages, and we offer these via the RPM format. So if you're coming from something like Fedora, this distribution will feel very familiar, both the package manager and actually the package format. And our core value proposition really is the around-the-clock protection from Microsoft. So every single one of these packages are built from scratch to ensure supply chain security. So throughout the entire build process, we know exactly which tools are being used to build the actual binaries. We sign the binaries, and then we do malware checks both after build and when we load the packages. All CVEs, all critical CVEs have a 5-day business day SLA for commercially supported images, which includes AKS. And apart from critical CVEs, we have a monthly release cadence for Azure Linux. So other CVEs that are maybe high, medium, or low, those would just get patched as part of our natural monthly release cadence. So on AKS, we are able to offer an OS SKU called Azure Linux that's managed by Microsoft for you. Within this actual OS, we offer the 6.6 kernel. We're offering Containerd 2.0, Runc 1.2, and a bump to systemd version 255. Your existing apps and pods would run on this Linux OS without any changes. So if you're using an Ubuntu-based container image or you're using a Red Hat-based container image, it doesn't matter because the underlying components are still Linux. Now, we asked a few guiding principles for the image we offer on AKS. I talked about how we have over 10,000 packages, but for the AKS image, we don't need that many. So what we do is we select roughly 400 packages that are needed to run Kubernetes well. Each of these packages, when we do upgrades, we actually run through a full end-to-end test suite on the AKS infrastructure so that those package updates don't cause breakages for our AKS customers. This same image is available for AKS, whether you're using AKS in the cloud or you're using AKS hybrid on the edge with your Arc-enabled clusters. Furthermore, Azure Linux is where we're innovating in areas such as kernel-level isolation and confidential computing, because that is where we're offering pod sandboxing and confidential pods. As I mentioned on the previous slide, the same around-the-clock protection applies to our AKS offering. So we follow AKS's release process. Every time AKS does a new VHD release, they'll pick up the latest versions of the Azure Linux packages. The 5-day critical CVE still holds. And one of the benefits that customers have bragged about is having one company supporting the entire stack, from the operating system all the way to the Kubernetes service. Let's take a look now at 3 common challenges faced by platform engineers and how Azure Linux can help them. The first one is resiliency. So some of the challenges you may face with resiliency are outages. So I have OS upgrades that are causing my service to have frequent reboots or downtime, leads to money lost and a poor experience, or I have to deal with regressions. So after an upgrade, there is a regression to my service. Now, how does Azure Linux help with this or prevent these? So I talked about how we do rigorous package testing. So anytime we do a release on any package that is in our AKS VHD, we are actually gating the release of that package on AKS end-to-end tests passing. This further increases the chances that our package releases will not affect customers. It goes through additional scrutiny, specifically for AKS. We also keep major package versions stable. So components such as containerd, runc, kernel, stuff that is core to keeping your container workloads up and running, are stable during LTS versions with Azure Linux. So what this means is if there is a critical patch in a containerd version, let's say 2.1 in the future, we will take care of backporting just that patch without all of the other maybe improvements and features to prevent breakages, but still make sure that you're secure. Second challenge you may face is performance. Specifically, upgrades can cause performance regressions, so you need to deal with those as a platform engineer. And poor performance is impacting apps. So app teams may come to you and say, hey, my app is tuned for performance, but it's the infrastructure that's causing perf challenges. How can you help? Well, with Azure Linux, given the smaller footprint that I discussed, so roughly 100 to 200 fewer packages than other distros, we have had customers, first-party teams like Xbox Gaming Services, talk about faster pod startup times and faster operations. Even beyond that, to prevent performance regressions as an operating system gets more and more updates, we test AKS ETE perf on package updates. And if there's any regressions, we'll actually halt the release. The tests we do specifically include cluster operations, so all the CRUD operations on your cluster, but we also do node-specific tests using industry standards like Sysbench, FIO for file input-output, iPerf, which is a common test suite for Kubernetes network perf tests. The third fundamental, in addition to that, here's a graph that shows some of the faster cluster operations time at scale on AKS. So on cluster creation, Azure Linux versus other distributions, and cluster upgrade time of Azure Linux versus other distributions. It's a sizable difference that we see. And this type of monitoring is something that we have over the course of months. So we can see changes. If there's a dip or an increase in the Azure Linux time, we'll investigate why that happened. The third fundamental benefit of Azure Linux for platform engineers and teams is security. Some of the security challenges that people face is CVE overload. So my SecOps team is coming to me and complaining to me about CVE vulnerabilities on my infrastructure. There's some uncertainty around how security hardened the operating system is. It's using the secure defaults. Every single component in binary has so many configurations it can run in. Are those secure? And the last one is supply chain threats. These are the ones that sneak up on teams and are really hard to detect. But how do I verify that the binaries that are running on my cluster is what is being published initially? Azure Linux helps with all three of these. First, with CVEs, because we have fewer packages, Azure Linux actually just has fewer CVEs than other distros. Furthermore, for critical CVEs, we have a 5-day SLA. For high CVEs, we have a 30-day SLA. So teams can rest assured that their fleet will be patched within certain dates. Security hardening, all the major components, whether it's the kernel, containerd, have secure default configurations. This is reflected in us passing all level 1 CIS benchmarks. We also offer a FIPS-enabled image for free for those who need that level of compliance. And lastly, Azure Linux binaries are built from source and signed. Any modules that people are loading, in-tree or out-of-tree kernel modules, are only loaded if they're signed with the trusted key. Now, let me focus on one of the specific security advantages of Azure Linux, which is pod sandboxing with Azure Linux. One of the challenges platform teams face, especially when multiple teams are deploying on their fleet of Kubernetes, is multi-tenancy or isolation between pods. Azure Linux addresses this with something called pod sandboxing. You can run the exact same containers you have. There's an additional layer of separation where untrusted apps are running in a sandbox with their own kernel. So untrusted pods can run in an environment with its own kernel and Kata agent. This architecture is the baseline for future innovations like confidential pods. And the stack is similar. It's still 6.6 Linux kernel. We're using Microsoft's hypervisor, but we're also building on the Kata project to actually create utility VMs for these untrusted pods. Now, let's take a look at a demo that shows this in action. In this demo, we're going to show two things. First, I have a cluster that's running Azure Linux, and it is not running on Kata-enabled cluster. And we're going to see what happens when you deploy an untrusted app. So I have an existing application that's running. It's the storefront application, the AKS Quick Start. And let's take a look at this node. It has a single node. It's running all of the services, so the order, the product service. And I'm going to just watch what happens when I deploy an untrusted pod. So when I deploy an untrusted pod that causes a kernel panic, my entire node crashes. All of my existing apps will stop working. To prevent this, we introduce something we call pod sandboxing. So I'll switch context to a cluster that's enabled with pod sandboxing. So let's take a look at the pods. So I still have the same pods that are running. Now, if I look at this cluster's nodes, you'll notice that it's running a slightly different version of the kernel, which has the Microsoft hypervisor in it. And I will go ahead and deploy the same untrusted app. However, on this untrusted app, what I'll do in the pod spec is specify that the workload runtime class I want to use is enabled to run in a pod sandbox. You'll see that this container is running one command. It's echoing C to sysrec trigger. That particular command would crash the entire container. We're going to go ahead and apply this particular untrusted app to this pod sandbox enabled cluster. Once this container starts, unlike the previous example where all of the pods were sharing the same kernel, the whole node crashed. You'll notice that the node is still ready. The node that's running my existing apps is still fully functional. But just the untrusted app, which had the kernel panic, is now running with an error in a loop. This is because that particular pod is running in a sandbox with its own kernel. So any crashes that it causes at that layer will only affect that pod, but not other services running on that same node. This is a short demo that shows the power of pod sandboxing and allows you to create isolated pods that, despite any security flaws or catastrophic issues they cause, will only affect them and not other pods on the cluster. Let's go back to the slides and take a deeper look at how this works underneath the hood. Underneath the hood, pod sandboxing is using a few key technologies. I talked about how it's using a kernel that's enlightened with MSHV, which is Microsoft hypervisor. But when you're submitting a pod spec and the kubelet gets this request, underneath the hood, it's taking a look at that workload runtime class. If that workload runtime class has Kata enabled, it's going to talk to the Kata containerd shim. This particular shim then talks to Cloud Hypervisor, which is our on-node virtual machine manager, and it will spin up a brand new utility VM with its own kernel, own systemd, and a Kata agent inside that talks to this containerd to spin up those pods. If you didn't have that workload runtime class, containerd will go through its normal path of starting runc containers. Thank you so much for attending this talk on Azure Linux. I talked a little bit about some of the benefits of Azure Linux for AKS. I talked about what Azure Linux is. It's an RPM-based distribution that Microsoft's built from scratch, and highlighted one of the security benefits, specifically looking at pod sandboxing to create isolation between your pods. Thank you for your time.